you guys. In this video I will lecture about quadratic functions and their applications, which is section 3.1. So this is the first section in chapter 3. Alright, so I want to show you how to graph a function using a quadratic written in vertex form. So first I need to introduce what a vertex form is to you. Now, we're all familiar with the standard form of a quadratic function, and it looks like this, right? It's f of x equals ax squared plus bx plus c, right? Seen this before. If you remember when I introduced the quadratic theorem, I showed you this and I said it equal to 0. Well, same idea, but in this case we don't have an answer equal to 0. It's just a function written in this form, yeah? So this is a parabola. Now this is on the rule that a does not equal 0, okay? Because if a is 0, then this number right here, the coefficient of x squared is going to be 0, which means this is no longer quadratic because the x squared is going to disappear, yeah? So x cannot be 0. Now, if I give you a parabola that opens upward, basically I am telling you that a is actually bigger than 0. And if it's downward, I'm telling you that a is less than 0. Now what do I mean by this? Picture this right here. This is the graph of x squared, yes? A normal parabola. And as you can see, it's pointing upward. That means that the bowl itself is opening upward. So when this is the case, that tells you that the coefficient of x squared, which is a, so ax squared, this a is actually greater than 0, meaning it's positive. Yes? Now, if it was negative, the graph would look like this. The bowl is going to be opening downward. So over here, you have ax squared where a is actually less than 0. Therefore, it is negative. Okay? Now, from this, I want you guys to recognize what a vertex is. This point right here and this point right here, which is basically the center of the bowl. These 2 points are considered the vertex. Now, in algebraic form, the function in vertex form looks like this. This right here is a quadratic in vertex form. You have a, which is the coefficient of x squared, multiplied by x minus h. H is a value I'm going to explain to you in a minute. And then you square this pair of parentheses, and then you add the k to it. I'm also going to explain what k is. Alright? Now, from this form right here, you use this right here to find your vertex. And we call this the vertex form. Now, let me graph this, for example. Let's call this my vertex. This point right here is the center of the parabola I'm graphing. Yeah? And obviously it corresponds to a specific x value and a specific y value. Correct? So this point right here, the coordinates, which we usually say what? The first one is x, the second one is y, right? Well, these 2 coordinates are actually h and k. So when I say h and k, I mean the x and y value of this very point. Okay? And h is your x value, k is your y value. So over here, I'm basically saying f of x equals what? The coefficient of x squared times x minus the x value of the vertex squared plus the y value of the vertex. Yes? This is the vertex form. Alright? Now let's see how to use this. Here you go. Let's start with the first example in your notes. Over here, it says graph f of x equals x minus 3 squared minus 9. Okay? Now the question is asking you to identify the vertex, the x and y intercept, and the axis of symmetry. So here's your vertex, right? The v point. I usually write it like this. Write the v and then open up a pair of parentheses. Now, we said this point right here, h and k, correct? So that means what? The x value over here is going to be 3. And the y value is going to be -9. Now, here's a question. We have x minus 3 over here. So why did I write down positive 3 in here? It's because the original form, please notice the sign with me, is what? A times x minus h squared plus k. So in the original formula, I'm telling you that what's the sign inside the pair of parentheses is actually negative. Yes? So x minus, this remains the same. That means that the h is actually positive. 3, just 3. Now, had the h been negative, then it would have been a negative with a negative, turning this to a positive sign. So if you see an addition inside the parentheses, then you insert a -3. But since the sign matches the formula, you only grab the 3. Okay? So the h is 3. Now, for the k, it's a little more obvious because the original equation gave it to you as an addition. So you already know it's supposed to be positive when k is positive. So over here, the fact that this is negative means what? Means that this whole value is actually k. K is indeed negative. So basically I'm saying it's x minus 3 squared plus -9, which is what k is. Make sense? If not, you can pause the video, rewind, listen to it again. If you still don't understand it, please email me. Oh man, I wish I could just pause class and go, do you guys have any questions? Or are we good? And see the bored faces. I miss you guys already. Okay. Anyway, so we found our vertex. The next thing the question needs you to find is x and y intercept. So remember what we said. The x and y intercepts are the points where the function intersects the x and y axis, right? So for the x-intercept, y needs to be 0. And for the y-intercept, x needs to be 0, right? So let's start with that. I'm going to grab my function and try to find those points. Now, for the y-intercept, we said x has to be 0. Which means what? Which means you're plugging in 0 into the function. I'm essentially finding f of 0, right? And this is my f right here. So let's plug the 0 in. We have what? 0 minus 3 squared minus 9. So 0 minus 3 is -3. Any number squared gives you a positive number. So 3 squared is 9. And 9 minus 9 gives you what? What does 9 minus 9 give you? 0. Okay, what about the x-intercept? For this one, we're returning y to 0. Yeah? And when we do that, we basically say what? That f of x itself equals 0. Correct? So to do this, I'm going to grab the value inside f of x, which is what? X minus 3, the whole thing squared, minus 9, right? And then set it equal to 0, because that's what f of x is. So now we solve. I'm going to grab this 9 over here, move it to that side, turn it positive, and you end up with x minus 3 squared equals positive 9. Now, I'm going to take the root of both sides. This square cancels with the root, and you end up with x minus 3. And over here, the answer of this root is going to be 3. on this side. And don't forget the plus or minus. So it's either positive 3 or negative 3. Yeah? And last but not least, negative 3 goes to that side, and you end up with x equals positive and negative 3 plus, oops, I forgot the 3. Positive and negative 3 plus another 3. So the two solutions over here is one of them, 3 is positive plus a 3 gives you 6, and the other one, 3 is negative plus a 3, and the answer is 0. Yeah? Now, we're not done. You need to give me the coordinates. So, for the y-intercept, it was what? 0.00, because we plugged in 0 for x, and we found y to be 0. Over here, you have 2. For both, y is going to be 0, because in order for it to be an x-intercept, y has to be 0. As for x, one is still 0, 0, and the other one is 6, 0. Alright? So, notice that now we have how many points? 1, my vertex, 2, 3. Now, you could have had 4, but in this case, the y-intercept and x-intercept happen to be the same because we have the point 0, 0. So, total, we have 3. 1, 2, and your vertex. Now let's try graphing this function using these 3 points. Here we go. Here are my coordinate system. X-axis, y-axis, 0, 0 is right here, right? And let's count. 1, 2, 3, 4, 5, 6. This is the point 6, 0. Now my vertex was what? 3 and negative 9. So at the point 3, I need to go all the way down to negative 9. So I'll put it right here. This is my vertex. And you could graph your parabola with this. That's my parabola. So we just graphed it using what? Using my vertex form. Now if you notice, at the point x equals 3, right here, what's happening? This being your vertex at positive 3 for x means that the function is technically mirrored across this vertical line. So if I fold this page in half, these two halves are going to line up exactly. This is the axis of symmetry of f of x. It's at x equals 3. Alright. Now, let's do another example. I'm going to wait a little bit, so if you guys want to pause the video, you can, instead of having to rush after me. Alright. Now, let's try one more time. Here you go. Another example. In this one, f of x is, let's see, f of x is negative. Notice you have a negative. Negative x minus 2 squared minus 1. So what's happening in this case? Remember, the formula says a times the pair squared plus k, right? Now the sign in the middle is negative, which means the h is going to be positive. So finding my vertex point, h is just 2, and over here plus negative 1, so it is a negative k, so negative 1. Yeah? I want you to also notice that your a over here, which is a coefficient of the pair, it happens to be 1 because there are no numbers written, yeah, is what? It's negative. The fact that it's negative means that the function is going to open downward. The parabola is going to look like this. It's going to be pointing down. Yeah? Now, but before we get to the graph, let's find the rest of the points. So let's find my x and y intercepts and the axis of symmetry. So, over here, let's start with the y intercept. So for the y intercept, we say what? X is 0. So Since x is 0, that means you basically plug 0 into the function, f of 0. So when I try to find f of 0, what's going to happen? We have negative on the outside times 0 minus negative 2. Oh, sorry, 0 minus 2. So answer is negative 2. Squared becomes positive 4. With the negative, the result is negative 4. Minus 1, and the answer is negative 5. Which means my y-intercept is 0, negative 5. Right? Okay. What about my x-intercept? For the x-intercept, you have y equals 0, which basically means that your f of x itself is 0. Which means I'm going to grab the function I gave you, which is negative times x minus 2 squared minus 1, and it's going to equal 0, because I'm setting it equal to f of x, which I just said is 0. Make sense? And then we solve for x. So I'm going to grab the negative, move it to that side, it turns positive, right? So you have negative x minus 2 squared equals positive 1. Now, since we have a negative on this side, I'm going to multiply both sides by negative 1. So I'm basically flipping the signs. This turns positive, that turns negative. Or you can multiply both sides by negative 1, divide both sides by negative 1. Still works. So, final result would be same pair, positive this time, equals negative 1. Now, once we got here, what do you think we should do? Because usually I'll just take the root of both sides, cancel this, and solve from there. But we encounter a problem right here, because you can't have a negative value underneath the root without going into complex. And when we're dealing with functions, we're not using complex numbers. In fact, I think chapter 1 would be the last place you actually see complex numbers. But anyway, so having a negative underneath the root, this automatically means there is no solution. And since there's no solution, you can't continue to find the two x values, which should tell you that there is no, what? X intercepts. So this does not mean that the function does not exist, or that the function is not actually a function, or that there's something wrong with it that you can graph it. No. It just means that the function doesn't intersect the x-axis. We're like, well, how is that possible? Everything is supposed to have an x and y value. It's like, that's true. But when you graph it, here. When you graph it, that means the function is going to be entirely at the bottom half. Meaning it will never cross the x-axis and will never touch it. So it's either in this half or in this half. Now, the reason I know it's in the bottom half is because when we started, I mentioned that it's pointing down and it's negative. Therefore, it has to be at the bottom half. Because if I drew it in the top half and it's pointing down, then it will at some point cross the x-axis. The only way for it not to do that is if it's in the bottom half already. Okay, so we found how many points? 2. The only thing we can use is 2 and negative 1, which is my vertex, and 0 and negative 5, because I have no x-intercepts. Yeah? So, let's do that. Point 2 for x, so 1, 2, and negative 1 for y. So this is right here, this point is your vertex point. Now, the y-intercept was 0 and negative 5. So 0 for x, and you go 1, 2, 3, 4, and 5, right here. 0, negative 5, this point. Now, this is where finding an axis of symmetry would be very helpful. Now, again, the value of the axis of symmetry would simply be the h value you have, which in this case is 2. Therefore, x is 2. This is your axis of symmetry. Which is, again, the x value of the vertex. So, if I draw an imaginary line, this right here will be your axis of symmetry. Now, why is that helpful? It's because the idea of the axis of symmetry is that it cuts the function in half and it mirrors it across the axis. So, this point right here, if you move 1, 2, you're on the axis. 1, 2, you are at the mirror value, which in this case would be the point 4. So 4 and negative 5 would be the other point you need to complete your function. See what I did there? So all I did was basically move on the horizontal line over here of y equals -5. And I moved until it touched the number of steps you need to get to the x value. So again, this is 2. This right here is x equals 2. Right? My point was 2, -1. So from 0, which is the x value for this point right here is 0, -5. Yeah? So from 0 to 2, we move how many steps? 1, 2. Correct? So again, at the half point, which is my axis of symmetry, I'm moving 1, 2. Again, I move 2 steps. So at the value of x equals 4, I'm going to go all the way down until I match this line where you have the y value of -5, and I'm going to draw a point. That's all. Alright, and that's your graph. Now, just for reference, let's go back to the previous example and show you that we technically did the same thing. We didn't have to actually think about it because x did give you intercepts. But just to demonstrate, here we go. X equals 3. That was my axis of symmetry. In the previous one, it was 2. This one is 3, right? Here's my vertex. Again, it halves it, right? It's at x equals 3. These are the these are the 2 points you need to actually graph the function. One of them was at the point 0, 0, right? And between 0 and 3 is how many steps? 1, 2, 3, correct? Okay, so now we're at the half point. We're at the axis. Again, we do it 1, 2, 3. You get to the other one. Now, these two are on the x-axis because for both y was 0. So that means that it's 0 here, 0 here, and the y-intercept was also the point 0, 0, which is why we didn't go up or down. But in this example, it was -5, which is why we're dealing with this line instead of that line. But the idea is the same. 1, 2, 1, 2, we move to 4, and you mirror this point over here. Kind of like we did with reflection, if you guys remember. Same idea. Alright, so that's how you graph this function. As you can see, it's pointing down. It never touches the x-axis. Yeah? Okay. Oh, let me pause a little bit. Hoping that this could help you copy. Okay. Now, let me do this. Okay. Now, I want to teach you guys how to find the vertex form itself. Okay? Now, there's 2 ways. One is algebraic. It's a pin in the, I'll let you fill in the blank. Pin in the blank. And it kind of resembles completing the square. But it's the more direct way of doing it. The other way is a lot simpler, a lot faster, and it's in the form of a formula, right? So it's a quick plug-in and you find the answer right away. I'm going to teach you both because you have to learn both. And on the test, I'm probably going to ask you to do both. So please pay attention. Here's the first one. How to find the vertex form using the initial or standard quadratic form of ax squared plus bx plus c. Right? This is how it usually starts. This is what a normal quadratic function looks like, where a does not equal 0. Now, let me give you an example. Say f of x is the following. 2x squared plus 20x plus 42. Okay, this is the function we need to find the vertex form of. As you can see, it looks exactly like that one. Now we want it to look like the form we just learned, which is this one. A times x minus h squared plus k. This is what you want it to look like after you're done. Alright? So let's start. There are a few steps. First thing you need to do is I want you to isolate the coefficient a. And you only do this out of the values you have where you have an x multiplied in there. So over here we have x squared, therefore you have an x. You factor out the 2 because that's your a, right? Over here you have an x, so I'm gonna factor out the 2 out of here as well. Ignore this one. Meaning, over here I'm taking the 2 out as a common factor. So 2x squared divided by 2 is just 2x, and 20x divided by 2 is 10x. Right? Now, leave a room and then close the parenthesis. After that, you add the 42. See what I did there? So I isolated the 42 on the side. Out of the first 2 values, I factored out the 2. Now here's a question. How would you know what to factor out? Easy. Whatever a is. So if I give you 3x, then 3 is what you factor out. If I give you 5x, then 5 is what you factor out. The goal here is to turn the coefficient of x squared to 1 by factoring it out, because you don't have 2 sides of the equality to mess with. All you can do is just take it to the side. So we take out the 2, and you do it from every single term where you have an x in there. Okay, that's why I ignored the last one, because it doesn't have an x. I left it over here. Alright, so the 2 is here now. I factored out the 2. We have x squared plus 10. Now over here, I need to add something that technically completes the square. Yes? So how would you figure out what that value is? I hope you guys have ideas. I can't exactly ask you, but I hope you have a clue. So what I'm going to do here is basically grab this, half it, and then square it, if you remember that rule. You grab the b value, right? So the 10, you half it, it becomes what? 5. And then you square the 5, and it becomes 25. Remember that one? From completing a square? We're doing this. So I take this 25 and I'm gonna add it over here. And then I'm gonna subtract it. Because if you only add it or only subtract it, what's gonna happen? You're changing the value of the function. The key here is that the fact that I added the same number and then subtracted it means that I added 0. So I nullified whatever it is I did. So the value of f of x remains the same. Yeah? So after all this, now we have what? Oops. F of x equals 2 times x squared plus 10x plus 25 minus 25 and plus the 42. There you go. Like that. Okay. Now, from here, what do you think I should do? This is where completing the square comes into play. This bit, one of these two 25s is going to go outside the pair parentheses and is going to be added to that 42. While the other one is going to remain in here, and I'm going to use it to complete my square. So, I'm grabbing the negative one. Can anyone tell me why? Well, obviously you can't tell me, but hey, I'm in class, so I'll pretend you're here. Can you guys tell me why? It's because if I take the negative one and move it to the outside, that leaves you with x squared plus 10x plus 25, which actually is a complete square. This right here, if you want to factor this out, you'll end up with the same pair of parentheses multiplied by itself, which is the goal. Yes? Which is why I'm doing this. Now, if I left the negative one, right, and removed the positive one, so the result you have would be what? X squared plus 10x minus 25. Then that will give you a problem, because factoring this is actually not going to match. Remember, the number over here is supposed to be the result of the multiplication, which means it's negative 5 times positive 5, because it's negative. But adding those two is not going to give you positive 10. Make sense? So, negative 25 wouldn't work, but positive 25 would. That's why that's the one I'm leaving in there. So, the 2 remains the same. All of this, without this 25, all of this is actually what? X plus 5 squared. Yes? And then you have the plus 42 and the minus 25. Does this look right? I mean, I grabbed the 25, moved it outside, and that's it. Does that look right? Well, there's something wrong with it. Because you see, over here, this 25 was inside the pair of parentheses that I initially drew. That is multiplied by what? By 2. So please notice that I multiplied the whole pair by a when I took it out, right? That means that if I want to take it out of that pair, it needs to get multiplied by that 2 first. So this is not actually 25, it's negative 50, right? It's 2 times that 25, so it's negative 50. And the addition between these two is going to give you negative 8. So it's 2 times x plus 5 squared minus 8. And this is your function in vertex form. Now looking at this, can you tell me what A is, what your vertex is, what H and K are, right? A is right here, easy to tell, is the number multiplied times the pair that's being squared, the one on the outside. That's A. So A is obviously 2. Now H is the number right here, so H is what, 5? Remember, the formula says it's x minus h squared. The fact that this is a plus means that this is x minus negative h. So together they give you the positive one, which means h is actually negative, not positive. And over here again, it's supposed to be plus k. The fact that you see a negative means that it is plus a negative 8, which means k is also negative. So my vertex point is negative 8 and negative 5, negative 8. Yeah? Now, I'm going to try to go down a little bit like this, hoping you could see the whole thing if you want to copy. I'm going to wait for a few seconds so you can pause the video if you want. Alright. Now, let me do another one for you guys. And in this one, let's try to play with it a little more. Let's try to find the vertex form of this function and then graph it. Okay? So we'll do both. We'll write the vertex form and we'll graph it. So we'll get more practice. Let's try. Here we go. That's number 4 in the notes. In this function, you have what? Negative x squared minus 2x plus 3. Alright, so first thing you need to do is find the vertex form. So, we'll start by factoring out the a, which in this case is 1, so that's good, but it's negative, so you have a negative to factor out. So I'm factoring out that negative. So negative x squared divided by negative is just x squared, and negative 2x divided by negative turns positive 2x, leaving a room, closing it, and then adding 3. Alright, this is my first step. Now second step, I need to fill in this gap right here. How do I do that? You grab this number right here, you half it, and then you square it. So doing that, half of the 2 is what? 1, right? 2 over 2. So grab 2, this right here, divided by 2 equals 1. And then you square the answer you just got. So 1 squared is the 1. Now this one right here, I'm going to insert in here. I'm going to add it, and then I'm going to subtract it to make the total equal 0. So after all of this, the function looks like this. It's negative times x squared plus 2x plus 1 minus 1 plus 3. Alright. Now what? I want to complete the square. So again, pick the one that actually helps you get a complete square. Multiplying a negative and a positive gives you a negative answer. So if I remove the positive one and leave the negative one inside the equation, you're not gonna get a complete square, because adding negative 1 positive 1 doesn't give you positive 2. The only one you can do it if you keep the positive 1 in there and remove the negative. So that's what I'm gonna do. That means that the negative on the outside remains the same. I'm keeping the x squared plus 2x plus 1. Right? I'm only removing the negative 1. All of this right here together, if you factor this, is going to give you the same pair of parentheses multiplied by itself, which is what? X plus 1 squared. Right? And then I'm going to add the 3 I have and the 1. Does that look right? I don't have a 2 over here to multiply the 1 by, so we're good on that front. Do I have anything else to multiply? Yes, I do. A negative. So the fact that I took out the negative 1 outside that pair of parentheses means it needs to be multiplied by this negative, which means the sign over here becomes what? Positive. Yeah? So that means I can add these two numbers. We have negative x plus 1 squared plus 4. This is your vertex form. Now, can you tell me what A is? A is the negative over here, so it's just negative 1, right? What's your H? It's obviously going to be negative since we have an addition in here. So it's negative 1. And your K is positive 4. And the vertex point is negative 1, positive 4. Yeah? So that's my vertex function. So now that I found this, let's use it and graph the function. Yeah? I already found the vertex. Let's find the x and y intercepts and graph it from there. Okay? So, for the x-intercept, like we just did, we plug in 0 for y, right? So, to do this, you need to have f of x itself equaling 0, right? So, I have this function right here is going to equal 0, which is what? Negative x plus 1 squared plus 4 equals 0. Yeah? Now, you could move the 4 to the side, it turns negative, and then multiply both sides by negative 1. Right? So, if you move the 4 to this side, it becomes negative, multiply both sides by negative 1, and turn both sides positive again just to solve it. Or, you can just move this to that side and end up with both sides positive already. Either way is correct. Alright? Now, take the root. This cancels with the root. And over here, root of 4 is 2, and it equals x plus 1. Just 2? Plus or minus. Always remember the plus or minus. Alright? Now, we have a 1. If I move it to this side, it turns negative, which means it's either positive 2 minus 1 or negative 2 minus 1 equals x. So, x is what? It's either 1 or negative 3. And your x-intercepts are going to be 1 and 0, and negative 3 and 0, because again, y has to be 0 in order for it to be an x-intercept. Alright, now let's find the y-intercept. Actually, I think I can do it here, since it doesn't take a lot of room. Y-intercept. For the y-intercept, x has to be 0, which means I'm finding what? F of 0. Okay, so my function was negative x, which is going to be 0, plus 1 squared plus 4, right? 0 plus 1 is still 1. You square that, the answer is still 1. You add the negative, now it's negative 1. Plus the 4, the answer is 3. Which means your point is 0 and 3. That's your y-intercept. So knowing all these points, let's graph the function. I'll do it right here. Okay, so let's start with the vertex. I'm going to go down a little bit so you can see it. Okay, let's start with the vertex. It's negative 1 and 4, right? So negative 1 for x, negative 2, negative 3, just for fun. And then we have 1, 2, 3, 4. Okay, so 1 and 4. This right here is my vertex. Now, the vertex being all the way up there, that tells you it's either a really big function that doesn't intersect x, but we know it does, or the fact that it goes downwards, which is the case. And that kind of makes sense since the function is negative. It's multiplied by negative on the outside, right? So, this is my vertex point. Now, let's plot the x-intercepts. First one is the point 1 and 0, which is right here. Second one is the point negative 3 and 0, which is right here. Notice that at x equals negative 1, we have the so-called axis of symmetry, right? Every time I graphed one, I showed it to you, and it is the same exact value of the x value of the vertex, the h, negative 1, every time. So the axis of symmetry is x equals negative 1, right? Which is right here. Now, we still didn't plot the y-intercept, which happens to be the point 0 for x, 3 for y, which is right here. Now, plot goes like this. Now, please forgive me, I can't draw. But this is your function. Now, out of curiosity, do you guys know what the domain and range of a polynomial function is? I mentioned it multiple times before, right? Domain is always what? Negative infinity to positive infinity. All real numbers. Always. Any polynomial is always all real numbers. The range, though, it does differ. Okay, so what about the range? For this particular function, it's pointing down. That means that every single negative value of the y-axis is included. So it goes all the way to negative infinity, no problem. Now, for the positives, so everything above the x-axis, we go as high as the point 4 for y. You're not going to climb more than that. The vertex is as high as it gets, which means it goes all the way to 4. Now, is it going to be bracket or parenthesis? Look at the point. It's filled in. It's included, which means it's a bracket. All right? So that was that example. Again, I will backtrack so you guys could see the entire question. And I'm going to pause for a few seconds so you can copy it if you'd like. Here's the first part. All you have to do is just pause the video. I'm just giving you enough time so you don't have to rush after me. Alright, and here's the second half of the page. Again, just pause the video. Alright? Okay. So, now, let's let me show you how to find the vertex form using the vertex formula, which is really easy, really easy. Okay, here you go. So for this one, this is what you need to do. The formula says that finding the vertex is as easy as finding the points of x and y of that vertex point using the standard quadratic equation. Using the standard quadratic equation, yeah? So, f of x over here is a x squared plus bx plus c, right? And if I give you x to be in this form, so this is the formula you use to find x, it is negative b over 2a. Yeah, that's it. So to find x, you grab the b over here, you plug it in the top, and you grab the a and you multiply it by 2 and put it in the bottom, and then set it to be negative. Okay, this is x. Y is f of b minus 2a. Negative b over 2a, sorry. What do I mean by that? I mean that you grab whatever this value equaled, right? You grab that answer and you plug it into the function I gave you. You find the answer, and that's your y. Make sense? Meaning, for example, here is a function. Actually, let me go like this so you can see both. Okay, so here's a function. It is what? Negative 3x squared plus 48x minus 165, and I want you to give me the vertex formula. Sorry, or give me the vertex using the vertex formula. Yeah? So that would be super easy. All you have to do is the following. You go, okay, x is negative b, which is 48, over 2 times the 3, which means it's 6, right? It's negative 48 over 6. And y is f of that value. Correct? Now, this right here equals what? Oh, sorry, it's negative, so it's actually going to be a positive number. But anyway, so what is that value? 48 divided by 6 is 8, right? So over here, I'm basically finding f of 8. It's positive. So I'm going to grab 8 and plug it into this function, which equals, so negative 3 times 8 squared plus 48 times 8 minus 165. And you can use the calculators. If I'm not wrong, the final answer would be 27. So your vertex is h, which is the x value, so 8, and k, which is a 27. Done. Isn't that a lot easier than trying to use the vertex form? Now, just for fun, although I'm sure you guys don't think it's that fun, I'm going to show you the other way too. So just to confirm that we got the right answer, I'm going to find the vertex point using solving for the vertex form instead of using the formula. So I'm going to do this a little bit quicker just to show you that they work the same way. Alright, so we have negative 3 taken as a common factor, and then you get x squared minus 16x, because the 48 divided by 3 gives you 16. I'm leaving space, and then I'm subtracting the 165. Alright, now 16 divided by 2 is 8. Grab the negative with it. Divided by 2 is 8, negative 8. And once you square that, that gives you what? That gives you 64. So I'm grabbing the 64 and I'm adding it and subtracting it from the main part right here. Yes. Now I'm keeping the positive one inside and taking the negative one outside. So I end up with negative 3 times x minus 8 squared minus 165 plus 3 times 64, because it was negative and this negative, that's why it's turned that one to positive. And the final answer should be negative 3 times x minus 8 squared plus 27. And if you remember from the formula, we said the value over here is h, so that's 8, and k is 27. They're the same. Yeah? So as you saw, the vertex formula is a lot easier. All you have to do is use these two right here. And what A and B are, you use the standard formula you have in the initial question. So you grab this number, that's your A, this number, that's your B, with the negative. And once you find this x, you plug it into the function, you find y. And those 2 points are going to be your vertex. Simple. So I hope you guys understood this one. If you have any questions, let me know. All I need from you is just like once you ask me a question, make sure to like include the time or the timestamp in the video. Like right now, as I'm talking, it's 52:10, for example. So you tell me at minute 52, 13 seconds, I want you to explain that part again, or I didn't understand when you did this. That makes it easier for me to pinpoint what you're talking about and be able to answer your questions a lot quicker. But yeah, don't hesitate to email me as many times as it takes for you to get it. Try watching the video again. If it doesn't help, let me know. I could try to make more examples. And yeah, stay safe.